Hello, class. Today we will be looking at applying several of the definitions that we looked at in the previous section using the algebra that we learned last year. The first thing I want to do is review which terms would suggest that we are going to be setting up an equation where the measurement of two objects is equal, when we will need to add to equal 90, and when we will be adding to equal 180. These are the forms of the equation that we will need to be setting up in order to solve the following problems. In a moment, I will have you pause the video so that you can add vocabulary terms to the right side of the table for each of these options. For example, if two geometric figures are congruent, then their measurements will be equal. So I can put in the term congruent in the right-hand column. And this will not be the only vocabulary word that will allow us to set up our first type of equation. Let's pause the video and give yourself about 5 minutes to see what other terms you can come up with to add to the right-hand column for each type of equation. How many geometric terms did you come up with? I'm showing my answers here. You should at least have these terms added to your table. Were you able to come up with any additional terms? Great! If you need to pause the video to make sure that you have these terms, please do so. In the next section, we will be answering questions about the line segment that is shown here. Question 1 also lets us know that point B is the midpoint of the segment. With that information, I will start by labeling my picture, not by setting up the equation. I do this to make sure that I have a good understanding of what parts I'm dealing with. The big question we need to answer here is, do I have a total, or am I just dealing with the two smaller parts? And what is midpoint telling us? If we label AB as 3x plus 2 and segment BC as 5x minus 10, we can see that we are going to be dealing with both the smaller parts of the segment and not the total, which means we will be setting these two equal to each other since the midpoint will cut this segment into half or two equal pieces. Let's set up the equation as 3x plus 2 equals 5x minus 10 and solve. Go ahead and pause the video here and solve this equation on your own first. When solving, we should get an answer here of x equals 6. Let's go ahead and see how you did. When solving this equation, I need to make sure I get like terms on each side. So I'm going to go ahead and take my x's to the right-hand side. To do so, I'm going to subtract 3x from both sides. My 3x's cancel, and I get 2 equals 2x minus 10. Now I want to bring all the numbers to the left-hand side, and I'm going to do that by adding 10. I'm just using the opposite sign of what I have. The 10's cancel, and I get 2x equals 12. And then I want to go ahead and divide here by 2 because right now there is a multiplying by 2 there. So I'm going to go ahead and divide by 2 on both sides. And finally we get x equals 6. Question 2 asks us to find the measure of AC. We will need to substitute a 6 in for the x in the 3x plus 2. So where I see an x, I'm going to go ahead and replace that with a 6. So 3 times 6 plus 2 instead of 3 times x plus 2. 3 times 6 is 18 plus 2. That gives us 20. If we do the same thing with our 5x minus 10, we have 5 times 6 minus 10. 5 times 6 is 30 minus 10 is also equal to 20. And this makes sense because we wanted the midpoint to cut the segment into half or to 2 equal pieces. If both the smaller pieces are 20, that will make the total of AC equal to 40. Question 3 requires us to justify our answer. I would say that because B is the midpoint, AC is divided into 2 congruent segments, making AB equal to BC. Again, if B is the midpoint, AC is divided into 2 congruent segments, making AB equal to BC. You may need to pause the video here to make sure that you get down your justification as well as your work. Questions number 4 and 5 are using this new image to the right. See if you can identify the vocabulary words that would apply to the image. Pause now and try it on your own. Great. So did you come up with straight angles or a linear pair? There may be other words that would apply, such as adjacent angles, but linear pairs or straight angles will allow us to set up an equation to solve, since both of those terms gives us that we have a 180-degree angle here. Since both of these do represent supplementary angles, we would be able to set up our equation where we are adding each angle to give us a total of 180 degrees. Therefore, this x plus 20 and this 128-degree angle will give us a total of 180 degrees. We can write that as the following equation. X plus 20 plus 128 equals 180. Let's go ahead and solve this one. 20 plus 128 gives us 148. Bring down your x. I want to get all of my numbers onto one side, so I'm going to go ahead and subtract 148 from both the left and the right, and I get x equals 32. As justification, I can write that straight angles are supplementary, which means they add to 180 degrees, or I could use linear pairs and say linear pairs are supplementary, which means they add to 180 degrees. In 6 and 7, we see a new angle yet again. This time the angle is a right angle, or 90 degrees. We know this because of the little box in the corner. This time we will set up our equation as 3x plus 5 plus another 58 equals a total of 90. Here, the total of the angles is only 90 this time instead of 180. Solving this equation, we get 5 plus 58 gives us 63. Subtracting 63 from both sides, we get 3x equals 27. And therefore, when I divide by 3, I get x equals 9. My justification for this would be that that right angles are complementary. Or rather that I have complementary angles here. And those add to 90 degrees. Here are 2 additional problems, number 8 and 9, to try on your own. Please pause the video and try to solve. You should get x equals 21 and b equals 25 for each of these problems respectively. Here are the full worked out solutions for each of these equations. How'd you do?